Today we are going to talk about the last type of looping structure in Java, which is the for loop. This is probably one of the most common loops that you will use, and because of that we will talk quite a bit about different ways to structure our loops and how to increment through them. So you might be wondering, well, why would I use a for loop when I could use a while loop? Well, a lot of times you could use a while loop or a for loop for either. You could use them interchangeably. What a for loop is good for is when you iterate a set number of times. What does that mean? That means if you know that you're going to do a task 10 times, then you can just set your for loop up to have it execute 10 times rather than having a while loop that checks to see if it has completed the task 10 times. So this is an example of how a while loop would be set up. We would first create a starting point, then we would check to see if we were timed to finish. We would do whatever code we were going to do, and then we would increment our loop. And these three tasks of creating a starting point, determining where to end, and determining how to update happen so frequently within while loops that we created a for loop, which essentially bundles these three statements all into one. The for loop structure is going to have 3 slots. And the first slot is where we initialize our variable. And this is our loop control variable, which helps determine when the loop should be executed. Next, we define how to test this variable. So we check to see if I is, in this case, less than or equal to end. And then if we haven't reached our condition at the end of our loop, then we update our variable. So essentially what's going to happen is I'm going to start with I equal to 1. I'm going to check to see if it's start over. I'm going to start with I equaling to start. I'm going to check, is this value less than or equal to end? If it is, then I'm going to do whatever code I see in here. I'm going to increase I by 1, and then I come back up here and I check. Am I less than equal to end? If I am, I do this code again. I increment my variable. I come up here and I check. Am I less than or equal to end? I do my code again. I increment my variable, and this process continues. So the starting value is where I began, and then I essentially go back and forth between these two conditions until I have reached my finishing condition, and then I exit the loop. Now there's a couple different ways that we can work within our loop control variable. So this first point says if you declare the loop control variable inside the for loop statement, or you can declare it before the for loop. Here's the advantages to each. If the variable is declared in the loop header, then the scope of the variable is limited to the loop. So when you leave the loop, the variable dies. For many reasons, or for many times, it doesn't matter if the loop variable still exists when you're done. But if you care about what its value is when you're done, then you don't want to declare it in the loop header. In this example that I showed here, since I declared this variable I in the loop header after I leave my loop, so let's say I was down here outside of my loop, if I tried to print out my value of I would get an error because it would have no idea what I is, since I was declared in the scope of the for loop. Now, if you declared I before the for loop, and then inside the for loop simply said I equals, now the scope of the variable, it existed before the for loop, therefore it'll exist after the for loop. Another thing to note is that our loop control variable is updated at the end of the loop. And if the condition is no longer true, then the loop is terminated. So if I were to go through a traditional loop and I had, for example, for I equals to 1, I is less than 4, I plus plus. So as I go through this loop, and let's just say I printed the value of I. Okay, so as I go through and run through this code, I would start out with 1. 1 is less than 4. So right now, this is my value of I, and this is what gets printed. So I start out with the value of 1. Is it less than 4? Yes. So I print the 1. Boom. Now I increase 1. So now I is equal to 2. Is 2 less than 4? Yes, it is. So I print 2. Since this is just a print and not a print ln, the 2 will go on the same line. I increment my variable and I get a 3. Is 3 less than 4? Yes, it is. So I print the 3. Okay, I increase my variable. Now my variable is equal to 4. I come up here. Is 4 less than 4? No, it is not. So now I leave my loop. So when I leave my loop, my I value is actually greater than that exit condition. So in order to continue working, I have to be less than 4. And as soon as I equals 4, I leave the loop. Okay, so that's what we mean when we say that the LCV is updated at the end of the loop. And since it's no longer true, then we actually leave the loop. Now, this last point that we have down here is very important. You shouldn't change the loop control value in our loop. This should only be modified in the for loop header. And the reason why is because this can result in that loop control variable being incremented more than once. So I'm going to show you an example here as I walk through this code, what happens. And this process of walking through code is also what we call tracing the code, and it's thinking like the computer. So in this case, I have a value of I, and I start out with I equaling 0. I check, is 0 less than 2? Yes, it is. So my first line of code in my loop is to increase the I value by 1. So now I is equal to 1. I've gotten to the end of my loop, so now my loop control variable, this update statement happens, which is I++. So now this is equal to 2. And then now I check my condition, is 2 less than 2? No, it's not. So the loop never runs again. And that's because it was updated 2 times on one iteration, and we don't want that to occur. On this next example, we are showing you how nested loops could occur. So this outer loop right here is essentially starting at character A, going until character D, and increasing the character by 1. Now you might be wondering how the heck that happens. Well, recall that we looked at the ASCII code values in our previous lesson. So essentially what's happening is when I say CH++, that is increasing the ASCII code value for the character A by 1, which the next character would be capital B. And so I will see that this right here, all of this is the first iteration of my value of A. So I set A or character equal to A, and then I come in and I have this inner loop. And the inner loop starts at 1 and goes until it's equal to 3. So I will print it 1, 2, 3 times. And that's what I see here, here, and here. And then now that this loop is done and I've reached my max, it's going to bump me out and I come back up here and I increase my character by 1, and now I see the value of B. So I've got my character as B, and it goes through this loop, and all of these pink lines are all the next iteration of this outer loop. So it comes in here and now it starts again with I equaling 1, I less than or equal to 3, so it's going to print where CH is B with a 1, 2, and a 3. And then after it's finished doing those 3 cycles, it's going to kick us back out up top, and now CH turns to C. And then I do the same thing again. I run through those 3 statements with CH of C, and then I do it one final time with CH of D. So what I can see here is my outer loop controls the character, and my inner loop controls the numbers within that specific character. All right, to go ahead for this problem, I want you to determine the output. So pause the video and see if you can figure out what's going to print here. Okay, so I started going through this and I got all the way through my A equals 3 case. And then it started to seem pretty repetitive and I had a good idea what was going on. When you're tracing your loops, that's common practice that once you figure out what's going on, unless you have to write all of the output, you can essentially stop tracing. And so what I'm going to notice is that my outer loop is going to happen when A is 1, 2, 3, 4, and 5. My inner loop, since I have this condition where B is less than or equal to A, the smaller the value of A, the less times that this loop will run. Now you'll notice that these 2 lines of code are the same. So it's actually going to print the same thing both times. So when A is 1, I see this line printed double. When A is 2, I see this line printed double and then that line printed double. So notice I have 2 lines and then 4 lines. When A is 3, each of these lines prints double, so now I have 6 lines. And so when A is 4, I would have 8, and when A is 5, I would have 10. And essentially I can see, just like we saw with the character and the number on the previous page, that that A value stays the same for all rounds and the B value keeps on increasing. All right, our last example has another set of code to trace. Go ahead and pause the video and see what you think is going to print out. Before you go ahead and trace the code, I want to mention this little side note that I have here. The plus plus operator, we can either do it before or after the number. Now, if I look at this first scenario with the plus plus x, I increment the number first and then I print it. And its value does not change after the fact. In this second case, I'm going to print the value of 5, then I increment it. So if I printed it again, it would print the value of 6. And that's just important to recognize where that incrementing happens. When tracing code like this with multiple variables, it's really important to keep track of the current values for each iteration. So I usually label each of my variables. So I start out with A having a value of 4 and B having a value of 7. And then this do while loop always executes at least once. Num is going to equal A, so num is going to equal 4. And then while 4 is less than or equal to 7, which it is, I'm going to start a loop. And for this loop, I'm going to create a variable x, and x is equal to A, which is 4. And then I'm going to be doing a bunch of printing. So I want to keep track of what exactly is printing. And I'm going to print the value of num, which is 4, along with a new line character. So now I go down to the next line. And I'm incrementing num by 1, so this turns into 5. And then I finish the loop, so my x value increments, and this turns into 5. And then now I come in here again, and I print num, so I print 5. I go to the next line, I increment num to 6. I finish the loop, so I increment x. This turns into 6. And each time I keep on checking, is 6 less than or equal to 7, which it is, so I keep going. And I come inside and I print the value of num, which is 6. I increase num to 7. I increase my variable to 7. Still true, so I go ahead again. I print the value of num, which is 7. Go to the next line, increase num, increase my x. Now this is equal to 8. 8 is no longer less than or equal to 7, so I leave this for loop. And then this right here is essentially going to print a blank line, which I'm just going to show like that. And then now I increase my A value. So A has been increased to 5. I'm at the end of my do while loop and I check, is 5 not equal to 7? They are not equal, so I come back up here and repeat this process. And for my next iteration, I'm going to switch colors to red. And when I come back up here, num is equal to A. Well, now A is equal to 5. So let's just that's all done. Num is equal to 5. Is 5 less than or equal to 7? Yes, it is. So now I restart this process. X is now equal to 5. And I'm going to print the value of num, so I'll print a 5. I'll increase num to 6, increase x to 6, and then come back through, print num, increase num to 7, increase x to 7. I check, 7 less than or equal to 7? Yes, it is. So I'm going to print the 7, increase num, increase x. This is no longer true, so I leave the for loop, I print that blank line, and I increase A. So now A is equal to 6. And what you're going to notice is this process is going to keep on repeating. The next time through, since I'm starting on 6, I will only print the 6 and the 7. And then the last time through, I will only print the 7. Once I get to that point, and I've increased A, and 7 is equal to 7, then I will no longer run through this loop again, and I will exit. And so that will be my output. All right, that's it for today.